We are now on part 2 of Chapter 11, DHCP. In this section, we're going to talk about designing a DHCP infrastructure. Now, if you have only a single subnet, well, that's real easy. All you need is a single DHCP server. However, if you have multiple subnets, there are 3 ways to go. You can implement a centralized DHCP infrastructure, you can implement a distributed DHCP infrastructure, or you can implement a hybrid DHCP infrastructure. With a centralized DHCP infrastructure, there is only one DHCP server, only one server to worry about. And then when a workstation boots up and requests an IP address, the DHCP request travels across multiple segments to get to the DHCP server. The problem with a centralized infrastructure is that workstation DHCP requests might have to travel over many intermediary networks to get to that DHCP server, and the problem with that is it causes a lot of inter-network traffic. So another way to go is to use a distributed DHCP infrastructure. With a DHCP infrastructure, you have one DHCP server per segment. One DHCP server for each segment. And if you do that, there is much less inter-network traffic. Of course, the drawback is, instead of managing one DHCP server, you are now managing multiple DHCP servers. A third way to go is the hybrid method, and that's what we use at the Community College of Baltimore County. At each of our main sites, Catonsville, Essex, and Dundalk, we implement a centralized DHCP infrastructure, meaning we have one DHCP server at each individual site. So when you design a DHCP server, if you have a single subnet, well, that's a breeze. But if you have multiple subnets, there are 3 ways to go: centralized, distributed, or hybrid. Let's discuss regulating network traffic. If you find that network traffic is excessively high and you want to find some way to bring that network traffic down, there are 2 ways to go. One is to implement a distributed DHCP infrastructure, and the other is to increase the lease duration. Recall earlier we discussed the lease duration. If you increase the lease duration, the default is 8, but if you increase it to a higher number, such as 16, then what that's going to do is decrease your network traffic. If you increase the lease duration, then that will decrease network traffic. Let's discuss planning for DHCP fault tolerance. 3 ways to go: split scopes, using a standby server, or implementing fault tolerance. If you have split scopes and you have 2 DHCP servers, they should have non-overlapping scopes. Suppose you have 2 DHCP servers and they have identical scopes. Both of these scopes go from .2 to .254, and this scope also goes from .2 to .254. So if 2 workstations boot up at the same time, this DHCP server will issue IP address 10.20.0.2 to this workstation, and this DHCP server will issue the same IP address to this workstation, and that results in many duplicate IP addresses. So, if you are going to have 2 DHCP servers, you implement split scopes. And what that means is half of the scope is on one server and the other half of the scope is on the other server. When we implement split scopes, that means we have non-overlapping scopes on the DHCP server. Another way to go is using a standby server. Standby server means we have another DHCP server in the closet. And if our DHCP server goes bad, we go in the closet, pull that server out, plug it into the cabling system, and then it can start issuing IP addresses to DHCP clients. Of course, the problem is, if that happens when we're away, then we got to get in our car and drive to the office and take that server out of the closet and connect it to the cabling system. A better way to go is to implement failover clustering. Here's how failover clustering works. It means we have two DHCP servers and one is a mirror image of the other. The first DHCP server issues IP addresses to DHCP clients, and the second DHCP server doesn't do anything. When the first DHCP server crashes, then the second DHCP server kicks in and issues IP addresses to DHCP clients. So, three methods of DHCP fault tolerance: split scopes, standby servers, or failover clustering. Now let's discuss DHCP and IP version 6. As you know, IP version 6 has a 128-bit address space, and the IP address is written in a hexadecimal format. And you can manually assign IPv6 addresses to clients, but that can be awfully inefficient and time-consuming. Typically what we would do is we would use DHCP to assign IPv6 addresses to clients. It's very similar to DHCP for IP version 4. The DHCP client powers up and sends a signal to the DHCP server. The DHCP server has a scope or a range of IPv6 addresses, and it pushes the first available address down to the client. IP version 6 for DHCP, very similar to IPv4. Now, what if the DHCP server goes down? If the DHCP server goes down, then the client generates a temporary IP address, and this is called a linked local address. If the DHCP server goes down, then the client auto-generates a temporary IP address, and this is called a linked local address. If we go to the command prompt and we type ipconfig, we can see that this computer has a linked local address of FE80. That indicates that it's a DHCP client for IPv6, and it could not hit the DHCP server. The way that the linked local address is generated is it's based upon the MAC address. What it does is it takes the MAC address, which is only 48 bits, and it adds an additional 16 bits, and that's how the linked local address is generated, based upon the MAC address. So there are three methods of assigning IPv6 addresses: manually, which is also called statically, using DHCP, or if the client can't hit a DHCP server, it can generate its own temporary IP address, and that is called linked local. Now let's look at configuring the DHCP server for IPv6. It is similar for IPv4, but there is one big difference. And the difference is that DHCP for IP version 6 has these two different modes: the stateful mode and the stateless mode. When we configure DHCP, we can select to enable the stateless mode, or we could choose to disable the stateless mode, which is another way of saying enable the stateful mode. It's a little confusing. You can enable the stateless mode, or you can disable the stateless mode. If you disable the stateless mode, then you are enabling the stateful mode. The DHCP stateful mode works just like IP version 4. The clients receive the IPv6 address and options from the DHCP server. Nothing new there. But the stateless mode is what's different. When we implement the DHCP stateless mode, the clients do not receive an IP address from the DHCP server. The clients auto-generate their own link local IP address. And the clients do receive other variables from the DHCP server. The clients receive the options from the DHCP server, such as default gateway, DNS server, and DNS suffix. With DHCP and IPv6, you have these two modes. Stateful mode is where the client gets its IP address and options from the DHCP server, and stateless mode where it only gets options from the DHCP server. Now let's discuss the DHCP relay agent. Routers, as you know, routers block DHCP broadcasts. And the purpose of a DHCP relay agent is to push the DHCP client requests through routers. When we use a centralized DHCP infrastructure, we have one DHCP server and we have DHCP clients which might be on other segments. The purpose of the DHCP relay agent is to take the DHCP client request and to push it through routers so the DHCP client request will reach the DHCP server. Now let's discuss DHCP relay agent placement. If we have a DHCP server here, we do not need a DHCP relay agent on the same segment. The DHCP relay agent is placed on segments on which the DHCP server is not located. To install the DHCP relay agent, we select Add Role to add the network policy and access service, and then we go into Routing and Remote Access and select New Routing Protocol. So I go to Server Manager, and under Manage, I select Add Roles and Features. I click on Next, and I select Role-Based Installation, followed by Next. I select the server onto which I want to install the DHCP relay agent, followed by Next. And then I go down and I select Remote Access. Notice, Remote Access provides routing capabilities and other connectivity options, specifically the DHCP relay agent. I click on Next. It tells us these are other features that are required for the DHCP server. Do we want to install them? And we say yes. Then we click on Next, followed by Next. Click on Next again. And then under Role Services, we make sure to click on the checkbox that says Routing, because the DHCP relay agent is considered to be a routing protocol. I click on Next and Install, and then the DHCP relay agent is installed on the server. To configure the DHCP relay agent, I click on Tools and I come all the way down to Routing and Remote Access. And then it starts Routing and Remote Access. And now we are at the Routing and Remote Access Management Console. As it is now, the system is not configured. So I right-click and I select Configure and Enable Routing and Remote Access. Then I click on Next, and it says under Configuration, select the options that you want. We want to select the bottom option for Custom Configuration. We then click on Next, and then we specify what services we want. We are going to select LAN routing because, remember, DHCP relay agent is a routing protocol. We click on Next, followed by Finish. We click on Start Service, and then it installs the DHCP relay agent. Then we go under to IPv4, and if we right-click on General, here is where we select New Routing Protocol. And you may have heard of the RIP, Routing Information Protocol, but we are going to select the DHCP Relay Agent followed by OK. We then right-click under New Interface and we specify which network interface card the DHCP Relay Agent will be listening on, followed by OK. And now we have the DHCP Relay Agent installed and configured. The purpose of the DHCP Relay Agent is to forward DHCP client requests through routers. Now, some routers can be configured to forward DHCP requests, in which case we would not need to configure a DHCP Relay Agent. Chapter 11, Summary. In this chapter we discussed static IP addressing, DHCP server, DHCP scope, DHCP options, and automatic private IP addressing. We looked at creating a client reservation, designing a DHCP infrastructure, DHCP fault tolerance, IPv6 and DHCP, and the DHCP Relay Agent. And this concludes Chapter 11. Thank you very much, and have a nice day.